Thanks for checking out our channel. This is going to be possibly a repair video on this unit here. This is a Power Wizard PW12000. It's a 12 output joule, so it has a pretty good, packs a pretty good walt to it. So we're going to take a look at this here and see, make any heads or tails of it, what's wrong. We don't get this model in for repair, but Power Wizard makes a 6, a 9, and 12, and 18 that are non-remote control capable units that are all basically the same setup, same transformer, different capacitors. Some have the same board, some have different boards in there, but they're all, the layout and the idea behind them are all the same. So it makes, when you troubleshoot a PW6000, 9000, 12,000, 18,000, troubleshooting wise all the same. So it makes my life easier, because if you do 20 of one or two of the different ones, you've done them all. Nice thing about these is these units are modulated. This particular unit, the numbers wore up. It looks like it's a 2015 model, so it's 10 years old. Don't know if it's ever been worked on or not, but 10-year-old unit either way. So, but we'll take a look at it here and see if we can get it figured out. If it's the first time you ever checked out one of our videos on YouTube, we appreciate you checking us out. And you want to subscribe to the channel. We got a bunch of videos, 1,000+ videos on YouTube of showing you how to fix things, test things, reviews, how-tos, anything like that on a bunch of different models. About every model you think of here in the States, old stuff, new stuff, we've probably got a video on it. Alright, so I'm not going to plug it in, I'm just going to take the screws out of it here. Let's see I think I heard some stuff going on the inside. This one's definitely been worked on, I think, at some point in time, because it's got a Phillips screw up here in the corner, which it's not even loosening up. It's just the whole thing spinning. So that means most likely that broke. The little piece here is supposed to be nice and long, going up about that high off the case, and that one's basically broke flush. So he put a longer screw on there, hoping that he'd grab a hold of it more, but it wasn't working. Alright, one thing I see already when I was first moving, it's missing the strain gauge down here that holds the cord in place. So bugs can get in there and look, hey, look, getting ourselves a bug right there. So bugs are getting inside the thing. Alright, let's check the capacitor first. That's the easiest thing to check. So I just unplug one wire, no matter if black, two black wires, you may have his left side, right side, unplug one of them. What we're doing there is, I don't know if you need to do it, but it's a habit I do. I'm just trying to take it out of circuit. That way, if there's any interference or something with the board, or there's extra capacitors on the board, it won't bleed into that capacitor and give us false readings of, odd, good or bad readings. This particular unit's got 60 microfarad capacitor in there, so let's go across there to there. There's no polarity to it, so we're reading 54.7, so probably the original one from 10 years ago, but it's got a plus or minus 5%, so yes, it's off a little bit, but it's not low enough to where I feel I don't want to charge it for a new capacitor. And look what we have here. Broken wire. A little tab right there. Could that be all that's wrong? Because if that is not on there, then this board and capacitor cannot discharge their energy into the transformer. You can see it's been arcing for some time. Black right there. I'm going to unplug both terminals, or both wires of the transformer. We're going to ohm across it first before I can crimp another one. I'm going to probably cut that wire, strip it back, because that's all burnt right there. I want to crimp on a good connector to a burnt spot. So just asking for trouble. So the primary of any electric fence transformer basically all read about the same. You just put it on ohms and lowest setting, just go across it. So it's a closed loop winding basically. So it should be between, the reading should be between 0.1 and 1 ohm. 0.1, 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. 0.9. That's not good. Almost 70 ohms out of that thing. Yeah, see, it should be like that, 0 point something. It should not matter on polarity because we're just doing ohms resistance, so it should not matter. Yeah, transformer might be having some problems. So what I like to do is, excuse me, is pull the transformer out. Even if it reads good here, I like to pull it out and inspect it. Sometimes you'll see these transformers start to get cracks or holes in the side of it somewhere, or you'll see it swell up in that little crease there where this piece and this piece kind of go together at. One piece, but you'll see in the crease there kind of swell up. That's not swollen. That ohm's awful high. So we might have a bad transformer here. But what we could do just to see. Oh, another thing that can go bad. Ooh, that no, the capacitor looks okay. I thought I saw something. We can check this diode. Right there, a big black diode there. Put your meter on the diode setting. You put your black lead on the stripe, white red lead on the non-stripe. Should read like, may or may not beep, but shouldn't be a solid beep like it's shorted. It should just beep once and give you some sort of reading, like that. See, beep gives the reading, so that diode is good, which is nice because those go bad. And usually when that goes bad, this goes bad. It's SCR right here. And we can check it just to see if it reads good or not. So put our meter, keep our meter on diode. We'll put our red lead on the tab, on the metal tab, which is the same contact point as the middle leg. Alright, didn't read anything, which is fine. I may have my meter backwards. Nope. The SCR is bad. So we've got, the moment, I think, a bad SCR and a bad transformer. So I gotta, I can put another SCR on there, not a big deal. I don't think I have any transformers in stock for this, so I'll have to probably order some in. Because we can put a new connector on there, plug it back on, it still ain't gonna work. What I may end up doing is just flashing a light, but it's not gonna click or pulse. So that SCR is bad, and then of course this could be bad too. It's a little transistor right there, or not. Yeah, bipolar BJT, bipolar junction transistor. That's what that is right there, that little one. That all this combination here tell this when to fire. It's like timing circuits, all this stuff right here. Tells this when the trigger, which when this triggers, that fires this capacitor through here, out of here, and these two prongs which go to your transformer. So there's more to it than that, but that's a simplified version of what's going on there. So don't think I'm going to fix this one today because I got to order a transformer for it. I got to get the customer price first, because if he doesn't want to fix it, then you know, what's the point of ordering the part? So I'll give him a price on transformer, price fixing the board versus or replacing the board if he wants to go that route, because the boards aren't super expensive for this model. But we can chat that over with him and see what he wants to do. But anyways, we got to get a strain gauge down here at the bottom so the bugs and stuff can't get back inside there, which I've got those in stock, I think. But anyways, thanks for checking out our channel here. This was not a, it was like a testing video more than a repair video, because I kind of have everything here to get it going. But there's our information. Until next time, see you guys later on.